2.7, calculate 1, the sum of the arctangent of 1 over 2 plus the arctangent of 1 over 3, 2, the arctangent of 2 plus the arctangent of 3, and 3, the arctangent of 1 over 2 plus the arctangent of 1 over 5 plus the arctangent of 1 over 8. And the hint says calculate the tangent of those expressions using the formula for the tangent of the sum and paying attention to the signs. Okay, so what does it mean? What's the hint saying? So if we have this expression, let's call it set. Okay, so set is the arctangent of 1 over 2 plus the arctangent of 1 over 3. What the hint is saying is that we want to compute the tangent of z and then see how this can give us some hints. Okay, so if we write the arctangent of 1 over 2 is x and the antangent of 1 over 3 is y, then the tangent of z is just the tangent of x plus y. Okay, and we know how to write this expression in terms of the tangent of x and the tangent of y, because this is the expression that we know. This is the expression tangent of x plus tangent of y, 1 minus tangent of x times tangent of y. Okay, so this is not a terribly important expression for you to remember, but if you know the expressions for the sum of the sine, so the sine of the sum is sine of x cosine of x plus sine of y cosine of x, sorry, this is sine cosine of y, and then the cosine of x plus y is cosine of x cosine of y, sorry, minus sine of x sine of y. Then these two expressions you need to remember, but if you don't know the expression for the tangent, well, you can just write this like this, and then substitute here. Okay, so you have sine of x cosine of y plus the sine of y cosine of x, and then the cosine of x cosine of y minus sine of x sine of y. Okay, and then if you divide both the numerator and the denominator by cosine of x and cosine of y, then dividing this term by cosine of x gives you tangent of x, and dividing it by cosine of y gives you 1, and then here again sine of y divided by cosine of y is tangent of y, and the cosine of x divided by cosine of x is 1, cosine of x cosine of y is 1, and then minus, and then you have tangent of x tangent of y. Okay, so this is the same expression. You can derive it pretty quickly if you know these two expressions. Okay, and actually that's what I do. I never remember this expression. Okay, it's too complicated for me, but I remember this two. So from this I can remember these two guys. Okay. Okay, so now the tangent of z is this. Okay, but now we need to know what the tangent of x and the tangent of y are. So, but if we have x is the arctangent of 1 over 2, then we take the tangent, and the tangent of the arctangent is just the argument. So the tangent of x is 1/2, and by the same token tangent of y is 1/3. So we just need to substitute here. This is 1 over 2 plus 1 over 3, and then 1 minus 1/6. Okay, so 1 over 2 plus 1 over 3 is 5 over 6, and 1 minus 1/6 is 5 over 6, or in other words 1. So we have that the tangent of z is 1, and so z, which is the expression that we wanted to, is just the arctangent of 1. Okay, and well, there are many numbers that fulfill this condition, because as you know, the tangent is also a periodic function, but typically we take the values of x between minus pi over 2 and pi over 2, so this will be pi over 4. Okay, the value of x, the tangent that makes the arctangent be 1 is pi over 4. Okay, sorry, I said it terribly. What I mean is that the angle that has a tangent of 1 between minus pi over 2 and pi over 2 is pi over 4. Okay, now the second part is just the same thing. Okay, you sum, we call z is the arctangent of 2 plus the arctangent of 3. This is x, this is y, and so the tangent of z is just the tangent of x plus y, and the expression again, tangent of x plus tangent of y, 1 minus tangent of x times tangent of y. And so now the tangent of x is 2 as before, and the tangent of y is 3 as before. So we have 5 and 1 minus 6. So this is minus 1. And so the tangent, sorry, z is the arctangent of minus 1. Okay, and the number that has the angle that has a value of a tangent of minus 1 between minus pi over 2 and pi over 2 is minus pi fourths. Okay, and finally, so a different one. So again, if we have z, let's call this arctangent 1 over 2 plus the arctangent of 1 over 5 plus the arctangent of 1 over 8. This is x, this is y, this is t, and so now the tangent of z is the tangent of x plus y plus z. But now, so the thing now is that we don't have an expression for this, but we can derive it. Okay, so we know the expression for the tangent of x plus y. So sorry, this is not z, this is t. We're going to make this not very clever trick. Okay, this is just a trick. Okay, so we're going to take x plus y as just the same number, so one block. So we have, using the expression for the sum of the tangent, 1 minus tangent of x plus y times tangent of t. And now what we do is we substitute here the expression of the tangent of x plus y that we already know. Okay, and well, I'm not going to do all of it, you can do it at home, but what you have at the end is the tangent of x plus the tangent of y plus the tangent of t minus the product of the 3 over 1 minus, and then the product 2 by 2, tangent of x, tangent of y, tangent of x, tangent of t, tangent of y, tangent of t. Okay, and as before, we know that the tangent of x is going to be 1/2, the tangent of y is going to be 1 over 5, and the tangent of t is going to be 1 over 8. Okay, so if we substitute here, we have 1 over 2 plus 1 over 5 plus 1 over 8 minus 1 over 8t, and here we have 1 minus 1 over 10 minus 1 over 16 minus 1 over 40. Okay, so if you do some algebra here, what you have is 40 plus 16 plus 10 minus 1, and here we have 80 minus 8 minus 2 minus 5, and what you have is this is 15, 16 minus 1 is 15, 25, this is 65, and then this is 80 minus 10, 70 minus 5, this is 65 over 65 equal to 1. So the tangent of z is 1. Z is the arctangent of 1. So again, z is pi over 4. Okay, the arctangent of this. And that is the end of the